Okay, another problem involving temperature. We have here the bronze sleeve that said it's slipped over a steel bolt and held in place by a nut that is turned to produce an initial stress of 2000 psi and the bronze. So the property of steel is here at cross-sectional area, modulus of elasticity, and thermal expansion coefficient, and for the bronze, the cross-sectional area, elasticity, and the coefficient, and the rise of temperature of 100 degree Fahrenheit for the whole system. The question is find the final stress in each material. So for easy analysis, we have to gather all the properties of bronze and properties of steel. Cross-sectional area of bronze is 1.5 inches square, and the modulus of elasticity is equals 12 times 10 to the 6 psi. Then thermal coefficient of 10.5 times 10 to the negative 6 per degree Fahrenheit. And we have the initial stress for bronze of 1000 or 2000 psi before the rise of temperature. And for steel, we have the cross-sectional area of 0.75 inches square, elasticity of 29 times 10 to the 6 psi, and thermal expansion of 6.5 times 10 to the negative 6 per degree Fahrenheit. Okay, so the change in temperature for the whole system is 100 degree Fahrenheit. So here we have the free body diagram. So it has already the answer and analysis in the manual. But how to understand and how to analyze this system? So when you discard, when you unplug the nuts or the bolt, and when you turn it back, so meaning this sleeve will be compressed and compress more when you turn the nuts for another turn, and for another turn, it will compress the sleeve. So that's why it is the compressive effect and the bronze, which is the sleeve. And of course, the action of the main bolt still is tension, because it will fight against the compression of the nuts induced by the nuts tornillo. Okay, we say that for bronze, before the temperature rise, we have the initial stress of 2000 psi. And for this, so when you sum up the force horizontal, so the axial load for steel is equals to axial load of the bronze. So it's incorrect to say multiply by 2, because actually it is this is the steel and this is another. So this is encapsule type. Only one material that surrounding the bolts is still bolt. That's why, so if it is the tension effect, the bronze will have the compression effect. This is bronze. Okay. Okay, so the forces horizontal is equals force of steel is equals axial force of bronze. So this is equals to P over A. So that's why this one will become stress multiplied by A for steel is equals stress multiplied by A for bronze. So we say for bronze, this is 2000 psi multiplied by cross-sectional area of 1.5 inches. And that is equals 3,000 pound. So since PB is equals PS, so therefore PS also is 3,000 pound. And the stress, initial stress of steel is equals 3,000 over 0.75 inches. And this is 4,000 psi. So because the temperature will rise, so the bronze will be strengthened by the amount due to temperature by this amount. But because this is compressive in action, the axial force were shortening by some amount. It will shorten again. That is due to initial. And this amount will be due to load or axial load, and that is for initial. And again, we have the, after the rise in temperature, we have the final stress. So in that will determine our answer. It will shorten again by this amount. And that is for due to load for final stress after the temperature risen to 100°F. So therefore, because this is one system, the elongation or the deformation of the bronze should be the deformation of the steel, because this is again, this is because of you turning the bolt, the nuts to hold the bolt into one system in rigid situation. So the total deformation of bronze should be the total deformation of steel. And from our analysis for bronze, this should be due to temperature minus due to initial minus due to final should be equal deformation due to temperature for steel plus, so it will elongate due to temperature and elongate because of axial, this is for tension, the axial force P will elongate the material. And for final, it will elongate again. For initial, plus due to loadings for final. And that is our equation. Okay. So we have the author assume the total freedom. But when you look at this geometry, you will get confused. So I just based on my analysis on the action of forces. So rise in temperature will elongate the material. And when the axial load will compress the material, it will shorten the material. And when the axial load is in tensile stress, it's elongate the material. So that's why I come up with this equation. Okay, so let us answer one by one for bronze. The temperature rise and bronze is, for bronze, this is 6.5, 10.5, 10.5 times 10 to the negative 6 multiply by 100 Fahrenheit multiply by length. And this is equals 1.05 times 10 to the negative 3 length. And for initial condition due to loadings, and that is PL over AE. This is equals 3,000 pound multiplied by length over cross-sectional area of 1.5 inches square multiplied by 12 times 10 to the negative 6 pound per inches square. And that is equals to 1.67 times 10 to the negative 4 L. And for final, due to loadings, because what we are asked for is the stress P over A of bronze or steel. So this is PL over AE. Or should we say this one is stress. So this is stress multiplied by L over elasticity. Okay, so for steel, For still, we have 6.5 times 10 to the negative 6 multiplied by 100 Fahrenheit equals, multiplied by L, equals 6.5 times 10 to the negative 4 multiplied by L. And for initial stress due to tension, that is equals 300 pounds multiplied by L again. This is 0.75 for cross-sectional area multiplied by elasticity of 29 times 10 to the 6. And this is amounted to 1.38 times 10 to the negative 4 multiplied by L. And for final, for steel, that is over modulus of elasticity. And that is PL over AE. P of bronze multiplied by E over AE. So this for final is different from 3,000 pounds. So from the equilibrium, we say that axial force of steel is equivalent to axial force of bronze. So let us say level this as P, just P. So from our original equation 1, okay, so substitute all the value. So this one is 1.5 times 10 to the negative 3 L minus 1.67 times 10 to the negative 4 L minus P L over 1.5 multiplied by modulus of elasticity. Modulus of elasticity of bronze of 12 10 to the 6. Equals. So this is for bronze. And this right side is for steel. So this is 6.5 times 10 to the negative 4 L plus 1.38 times 10 to the negative 4 multiplied by L plus P L over point cross-sectional area 0.75 and 29 E. 0.79. This is 29 times 10 to the negative to the 6. Okay, so this is amounted to 8.83 times 10 to the negative 4 L minus PL over 1.5, 12 times 10 to the 6 equals. This one is amounted to 7.88 times 10 to the negative 4 plus PL over 0.75 times 29 times 10 to the 6. So when you sum up that, so 8.83 minus 7.88, both multiplied by to the negative 4 multiplied by L, and then that PL over 0.75 times 29 times 10 to the 6. So this will be transposed to other, that is PL over 1.5 times 12 times 10 to the 6. Then we have 1.015 times 10 to the negative 7 P. So the L will be cancel out, is equals 0.95 times 10 to the negative 4. P is equals 935.66 pound. And that is the actual law that determines the stresses of our material. So the stress of bronze is equals final 935.66 pound over, this is 1.5. This is 623.77 psi, and for steel, this is equals 935.66 pound over 0.75 inch square. This is 1247.55 psi. And that is the answer. Okay.